The Victoria matrix. When geometry becomes an architecture for analysis, two decisions can appear equally rational. They may rely on the same information, offer the same opportunities, present the same advantages, and yet, one will lead to greater stability. The other will gradually create tension, fragmentation, and sometimes even failure. The difference is not always found in the information itself. More often, it lies in the way that information is organized, in the relationships it creates, in the structure it forms. That is precisely where the Victoria matrix begins. At first glance, the Victoria matrix may appear to be nothing more than a geometric figure, a polygon, a visual symbol. But it was never designed as a decorative shape. It is built upon an enneagon, a 9-sided polygon, constructed according to precise geometric proportions related to the golden ratio. Within the Victoria method, this geometry is associated with a property of resonance. That resonance is not an additional feature layered onto the matrix. It is the principle from which the matrix itself is derived. Its geometry comes first. Everything else follows. When this matrix becomes part of an artificial intelligence system, however, an essential distinction must be made. Artificial intelligence does not experience resonance. It does not perceive vibration in the way a physical instrument or a trained human operator might. Instead, the geometric principles of the matrix are translated into a logical and operational framework. In other words, geometry becomes the architecture through which analysis is organized. Resonance remains the originating principle. The analytical protocol becomes its operational translation. This distinction is fundamental. The AI is not asked to reproduce resonance. It is asked to reproduce the analytical consequences of a geometry originally associated with resonance. A conventional AI primarily processes information. It identifies patterns, finds similarities, calculates probabilities, and ultimately generates the answer that appears most likely according to the available data. The Victoria matrix introduces an additional step before that process even begins. Before searching for an answer, it first organizes the examination of the situation itself. It does not immediately ask, which conclusion is the most probable? It first asks something far more fundamental. How do the different elements of this system relate to one another? Do they reinforce each other? Do they contradict each other? Do they compete for the same resources? Do they create stability or hidden instability? Because a system cannot be understood by studying its individual components alone. It must also be understood through the relationships that connect them. A project may appear outstanding on paper and still be fundamentally incompatible with the resources required to sustain it. A strategy may generate impressive short-term results, while slowly weakening the organization that implements it. An opportunity may look ideal, yet conflict with the true objective it is meant to serve. Every individual element can be rational, and the system as a whole can still be incoherent. That is why the Victoria matrix does not simply weigh advantages against disadvantages. Its purpose is to understand relationships, because systems are not built from isolated components. They are built from interactions. This is precisely where the Victoria matrix seeks to reveal what is often invisible, not errors, not necessarily weaknesses, but dissonance. Dissonance does not mean that a particular element is wrong. It means that it does not integrate harmoniously into the overall structure. That distinction is essential. An idea may be brilliant, yet arrive at the wrong time. A decision may be perfectly logical, yet require resources that simply do not exist. A strategic direction may appear attractive, while gradually pulling the entire system away from its intended trajectory. Rather than judging each element individually, the matrix evaluates the quality of the relationships that connect them. Within an artificial intelligence system, the Victoria matrix operates through 3 complementary layers. The first is geometric. The enneagon remains the original structure, with its 9 points, its internal relationships, and its carefully defined proportions. The second is logical. The principles derived from the matrix are translated into analytical rules designed to identify convergence, contradiction, tension, available resources, structural vulnerabilities, and potential trajectories. The third is operational. The matrix becomes a protocol that is applied before the AI formulates its conclusion. It is therefore not merely displayed on a screen. It functions in the background as an orchestration layer guiding the analytical process itself. A practical example. Imagine someone trying to choose between 3 different career paths. A conventional AI can compare salaries, future opportunities, required skills, risks, and potential benefits. That analysis is valuable, but it often remains external to the deeper dynamics of the situation. An AI structured around the Victoria Matrix goes one step further. It also seeks to understand the long-term stability of each path, its coherence with the person's actual objective, the resources required to make it viable, the tensions that already exist, the risk of dispersion, the conditions that would be necessary for success, and the way each option is likely to evolve over time. Its objective is therefore not simply to identify the option that appears best in theory. It seeks to identify the one that integrates most coherently into the system as a whole. The same reasoning can be applied to an organization. A company may report impressive growth. Its financial results may appear excellent. Its performance indicators may inspire confidence. And yet, beneath those encouraging numbers, there may be an excessive dependence on a single client, a team approaching exhaustion, fragile cash flow, or a strategy that cannot be sustained over time. The numbers describe success. The structure may reveal vulnerability. The Victoria Matrix is designed to explore precisely that difference, the difference between what appears successful and what remains structurally coherent. The purpose of the Victoria Matrix is not to predict the future. It does not claim to eliminate uncertainty, nor does it replace human judgment or free will. Instead, it proposes an orientation based on the observable structure of a situation. It highlights what appears stable, what appears fragile, what strengthens the system, what risks fragmenting it, and which elements deserve closer attention before any important decision is made. Human judgment therefore remains at the center of the process. The human defines the subject, provides the information, clarifies the question, interprets the analysis, and ultimately makes the final decision. The Victoria Matrix is not intended to replace human intelligence. It is designed to provide artificial intelligence with a more structured way of examining complex situations before reaching a conclusion. Conclusion. Ultimately, the Victoria Matrix is not another artificial intelligence. It is an architecture positioned between the question and the answer, an architecture derived from a precise geometry, a geometry associated within the Victoria method with a property of resonance, a resonance translated into an analytical protocol, and a protocol designed to reveal coherence, contradictions, and potential trajectories before any conclusion is produced. Because an artificial intelligence can generate an answer that sounds convincing, but a convincing answer is not necessarily the right one. Sometimes, before trying to answer, we must first understand what holds a system together and what, beneath the surface, may already be drifting out of balance. That is the purpose of the Victoria Matrix: to understand systems before trying to optimize them.